Good morning. Good morning, everybody. So today is what we're going to learn today is we're going to use systems of linear and quadratic equations to solve problems. Now you may remember we've done systems before, and so when we were doing systems before, we had problems like, and I'm just making up a problem off the top of my head. We had a line that intersected another line. And one way we could find the solution was by just looking, where do they intersect? And we would say, in this case, they intersect at -0.4 for the x value, and then 0.2 for the y value. So these are what we call linear systems. You may be also asked, how many times do they intersect? You would say 1. You may be asked, how many solutions does it have? You would say 1. Okay, these go in infinite directions. This goes up and down this way. This goes up and down this way. Positive slope versus negative slope. And they have exactly one solution. And most lines have one solution. Now sometimes, let me see if I could think of one where they would be the same. If I had 2y is equal to 4x plus 2, notice they are the same thing. Okay. Here I'll put y equals to make it a little more obvious. Now how do I know they're the same? Well, this one's just a multiple of 2. Okay, so in this case, if someone said, how many solutions does these two lines have? You would say infinite. They intersect an infinite amount of times. If someone says, what is the solution? You would also say infinite. Now you could pick, if they wanted at least one solution, you could pick any solution you would like. Okay, but it's better to put infinite. So we have, when we're talking about linear systems, most of them intersect once. Sometimes we have infinite solutions, and other times we have what's called parallel. So if I keep the slope the same, and I could just leave it like that, you can see that these lines will never intersect. These lines will never intersect. How do I know they will never intersect? Because they have the same slope. They start off at different places, but the slope tells them to have the same steepness. Well, since they have the same steepness, they will never intersect. You could go look at these forever, and I know they look like they intersect, but you know, it's just because the numbers are getting quite large. But this is an example. If someone said, how many solutions are there? You would say none. What are the solutions? There aren't any solutions. They're parallel. So why am I covering linear systems, which was our last unit, again? Well, our goal for today is to do systems with linear and quadratic. Okay, so you can imagine the possibilities change when we're talking about parabolas. For example, if I want to change this to a parabola, I would just change that to the second power. And now we have what's called a system with a line and a parabola. And then you might be asked, how many solutions does that have? Well, this is where it gets kind of tricky, because I have taught you that solutions mean where does it cross the x-axis. And that is true if they're saying set it equal to 0. But when you have a system and they're asking you for the solution, they really mean where is the intersection. So like I see a solution there. I would say one of the solutions is -1, -1. And then there's another solution up here at 2, 5. Okay, I would not call these solutions in this case because, long story short, if I were to combine these together and use what's called the substitution property, then I would be looking for the x-intercepts. But because I have a parabola and a line, solutions mean where do they intersect. So I'd say -1, -1. I'd say 2, 5. If someone said, how many solutions are there? I'd say, well, there's 2. Okay. So that's what we're going to do. We're going to do parabolas with lines. We might do 2 parabolas. Oh, man, not that big. And so then I might be looking, okay, where do those intersect? Do they intersect? Uh-oh, I don't know. Yeah, those aren't going to ever intersect. And the reason why is because they have different y-intercepts and they have the same stretch factor. Okay, so this is an example of 2 parabolas where I would say there's no solutions. These parabolas will never touch. And then we might be doing parabola with the circle. How do I make this a circle? You just put this to the second power. Oh, sorry, that's a hyperbola. Maybe if I do negative. Yeah, so that would be what's called a hyperbola. We're not going to do hyperbolas yet. Let's see. What if I change that to second? Oh, there's a hyperbola. So with those, I know how to type those in, but I can't just change something on here. And I'll show you why. Actually, if I do to the second there, and I change that to negative, and then maybe that to a plus. There we go. There's the circle. And so then, and actually it's an ellipse. It's not a circle. So we have an ellipse, and then we have a parabola. What are the intersections? I would say 0.53, 1.562, 0.53, 1.562. Oh, that was negative 0.53. So this, I would say this has 2 solutions. This ellipse and this parabola have 2 solutions. Okay. So let's go ahead and start today's lesson. I found these notes out here. They're wonderful notes. And what I want you guys to see are like how many solutions something has. So here's an example of 2 parabolas. They're never going to intersect. These go down forever. These go up forever. So this has end behavior up. This has end behavior down. Where do they intersect? They never will. So I would say no solution. Here is an example of a picture where I would say they intersect once. And where do they intersect? Right there. What is that solution? Well, we can't see the number, so I can't tell you. Here, I see that this line intersects this parabola twice. So I would say 2 solutions. Now this one's interesting. So let's assume it doesn't go down any right there. It looks like it does. Let's say it just comes down, touches it, and goes back up. So I'd say there's a solution there, 1. There's a solution there, 2. Solution there, 3. So if someone said, how many solutions are there? I'd say 3. And then here, a parabola with the circle, I have 1, 2, 3, 4. 4 solutions. So you can imagine that the algebra for these can be quite difficult. And I love these notes, and I'm not claiming these as my own. I found them out on the internet. There's nobody to give credit to, but whoever you are, appreciate you and thank you. But so here's an example. So they have what's called a parabola and a line. Now, I teach this class for regular and I teach this class for honors. Okay, if you are a regular student, which if you're watching this now, you are regular, you're a virtual kid, all I need you to know how to do is how to type this into Desmos. And I give you complete permission to do that. So you would type this into Desmos, look to see where they intersect. If you're an honors student, and I let the honors students watch this video later, then I need to actually see the arithmetic of how to solve. And so here is the algebra. So you both have y equals, so we use what's called substitution property. So we could just set them equal to each other, and that's what they do. And then they move everything to one side, and then they factor, and they say like, look, the x-intercepts are 4 and -1. So we have to take that 4 and -1, plug it back in to find the y value. So a solution is the x and the y, not just the x. And so that's what they did here. Here we have a parabola. This is a circle. For the general student, how many solutions does it have? You should be able to say 1, 2, 3. What are those solutions? Again, feel free to type these in Desmos to get the solution. On your practice, just turn in the screenshots from Desmos. I am perfectly okay with that. But if you are an honors student, how do you solve these? I need you to actually solve these algebraically. And now, I'd be happy if any of you that are not honors students want to solve these algebraically, feel free to. I'm actually pretty impressed that you would want to. It's actually better that way, but just to keep it simple, these do get pretty difficult pretty fast. And so I am giving you permission to use Desmos, unless you're an honors student. Okay, but here I have y equals x squared. I have a choice. I could plug x squared in here for y, but then when I plug x squared in for y, then I'm going to square that and I get a quartic because 2 times 2 is 4. So it's better to take the x squared and put a y there instead. So instead of x squared, substitute a y, which is what they do. And then they do the math, and I'll let you read through the math yourself. And they get 0 and 3. So then they plug it back in to find the x values. And they get the 3 solutions. Okay. Here's another example. Again, regular student, how many solutions are there? 1, 2. What are those solutions? Type them into Desmos, get them that way. Honor student, solve it algebraically. Here's the work. Okay, those are out on my page. And again, I do give credit to whoever made this. It is very great. Here, regular student, how many solutions are there? 1, 2. What are those solutions? Type them into Desmos. Honor student, solve by hand. And so you can see, yeah, these get pretty tricky pretty fast. Okay, so again, the work is out there. I'm not going to cover any of these algebraically on the video. I'll let you read the notes if you would like to see those. Those are out there. My main goal today is, can you look at a picture or get the picture and tell me, 1, how many solutions are there? And 2, what are those solutions by looking at the graph? So that's my goal. But if you would like to know how to solve algebraically, I have notes out there. And then you could also solve these using elimination. And we talked about elimination already. And I mean, like I said, you can see these get pretty difficult rather fast, okay? So what I want to do is I just want to play around on Desmos. And before we do that, I want to show you your practice. And notice, this is probably the first time I've had regular versus honors. So you can see the instructions for regular. You do not need to solve these algebraically unless you want to. I just want you to tell me how many solutions each system has. What are those solutions? feel free to use Desmos and get the solutions. All I ask is that you turn in your Desmos graphs. Honor students, this is one of the first big differences in the class. I need to see your algebra work. And so if I open up the practice, you can see, again, I mean, I'm not going to repeat the instructions I just said, but this would be a circle, and that would be a line. This is a parabola. So parabola. This is a line. I know it's a line because it's to the first power. This, anytime you have x and y squared, it makes a different kind of shape besides a parabola. It could be a hyperbola. It could be a circle. It could be an ellipse. Now, I'm trained in this and I've taught units over what's called conics, and I know this is a circle. And I'll show you some circles here in a second. So this is a circle, and this is a line. Where do they intersect? This is a parabola and a line. Where do they intersect? How many solutions? Here, that's a circle and a line. How many solutions? Where do they intersect? Parabola and a circle, same thing. Parabola and a parabola. Circle and a, oh, I'm sorry, that is not a circle. X is not squared. That's a parabola and a circle. Okay, so you can see this lesson just got a lot easier for, well, I guess you could call them regular students. So let's start and play around in here. I first want to talk a little bit about circles. So if you have, say, x squared, and you say have plus y equals 4, that's a parabola. As soon as I type this as y squared, it turns into a circle. There we go. Now, what's very kind of cool is anytime you have x squared plus y squared, it's always going to be centered about the origin. And the radius comes from the 4. You take the square root of 4, you get 2. So the radius is 2. So I can actually make this radius bigger by like changing that to 9. Now the radius is 3. See that? And again, if someone said, what is the solutions? Because we're only talking about one picture, I would say 3, 0, and negative 3, 0. But if they're talking about more than one graph, then we're not talking about the x-intercepts. But notice, as I make this into bigger numbers, I make the circle bigger. And then if I want to move it left and right, kind of like when we were doing a vertex form, I could do, and let's not make this such a large circle. So this number here moves it to the right. Kind of cool, huh? And then this number moves it up and down. And again, you're not responsible to know this. So I can change that to 3, move it up, see? So there's a lot of similarities between vertex form and other shapes. So let's say I had this circle, and I was typing in a random, off the top of my head, a line. So to be a line, it would have to be to the first power. Let's do 1/2 x. That works. So then, how many solutions are there? 2. What are those solutions? So that's going to be an approximate value. If we wanted the exact value, we do need to solve these algebraically. I am okay with an approximate value, but I would say 4.273, comma 2.137. The other one, you can see yourself. All right, what if we did 2 circles? Let's make this a little simpler. That works. What if I did x squared plus y squared, equals 9. How many solutions? Well, 1, 2. What are those solutions? You can see for yourself 1.4-ish, comma, you have to put the x and the y. 1.452, comma, 2.625. Over here, negative 1.452, comma, 2.625. Perhaps let's do that. What if I oh, that's not what I wanted. There we go. Took me a second to think of that. So now what are the solutions? How many? 1 at 0, 2. They intersect at one spot. We could have parabolas. Again, these are all made up. I'll make one upside down. Upside down, I'll just have to put a negative there, right? And then we'll do x squared. And then I want them to intersect, so I'll move it up. So I'll do like plus, I don't know, 8. Ah, yeah, that works. So how many solutions? 2. 1, 2. What are those solutions? And again, these are going to be approximate values. Those are not exact. You can see that solution, and you can see that solution. Those are the 2 solutions you'd write down. Now remember, you could have something like this where they never intersect. So you would say, no solutions. All right. I know this was a little bit kind of a different lesson than what you're used to. There's really nothing else to add. I'll say, like, if you want to solve these algebraically, there's the notes. Those are out there. Your practice, once again, you could just type this into Desmos, and you're going to answer how many solutions, what are the solutions. So it shouldn't take you too long. And I do need just 1 second. I do need to make sure that our quiz is okay. So here we go. So again, what are the solutions? You can use Desmos. Yeah, all of these you can use Desmos on. Okay, so I'm pretty sure the solutions are whole numbers. But anyway, that is all I have for today. Thank you for joining, and I will upload this video out there to YouTube so that you could watch it later. Have a nice day. And again, this is Mr. Parks. Nice seeing you.